Okay, so we've got a couple of things that we're going to take care of here. Scale drawings. So first of all, our learning target for this lesson, I can determine the scale factor. Okay, and that's going to be a number. What do we multiply any value by on our scale drawing in order to replicate the actual item? And second, I can use the scale factor to determine the size of actual objects. Okay, so a couple of things, a couple of definitions here. Scale drawing, a proportional drawing of an object that makes it possible to represent objects accurately that are either too large or too small to draw at their actual size. So a reduction, a scale drawing that is smaller than the actual object. A great example of that is a building. Okay, a jet airplane. All kinds of different objects that we know are too large. Football field. We don't draw out a football field in real size. Okay, those are great examples of reductions. Enlargement. A scale drawing that is larger than the actual object. You may or may not have heard of nanotechnology. That means that we're talking about really, really small components. So inside of a computer, there are a whole bunch of chips. And those computer chips are hard to draw as small as they can actually make them. So you might have something like a computer chip. Okay, a molecule. Or an atom. In science class, you don't draw an atom the actual size because atoms are microscopic. So you have to draw them so that they look larger. And that would be an enlargement. So the scale is the ratio between two sets of measurements. Okay, so we're comparing two different sets of measurements. The ratio compares the measurements of the drawing to the measurements of the real objects. All dimensions are reduced or enlarged using the same scale. You can use the same units, like 1 inch is the same as 30 inches, so 1 inch on a drawing is the same as 30 inches on the actual object, or different units. 1 centimeter is the same as 1 meter. Okay, when you're dealing with maps, we can't use the same units because we're talking about miles instead of inches. When you look at a map, you're looking at inches. When you look at the actual ground that we are traveling, you're looking at miles. 1 centimeter to 1 meter, or 1 centimeter equals 1 meter. So 1 centimeter on the drawing is 1 meter on the real object. The scale is used to compute the actual dimensions. And blank can be used. What are they looking for there? Not sure. The scale is used to compute the actual dimensions. Anyhow, moving on. Example number 1. On a road map of Ohio, the distance from Cleveland to Pittsburgh is 4.5 centimeters. Well, obviously it's not 4.5 centimeters from Pittsburgh to Ohio. What is the actual distance between the cities if the map scale is 1.5 centimeters equals 30 miles? So here we set up our proportions, just like we did in the last section of work that we accomplished. So we know that 1.5 centimeters is the same as 30 miles. Well, we find the other mention of centimeters right here. And so that has to be in the same location in the second fraction. And what we're looking for is the actual distance. So we put in our variable. Okay, and now, ignoring the units for now, we cross multiply, just like we've been doing. And we take 1.5 times x, we get 1.5x. And then when we take 30 times 4.5, we get 135. And this is an equation like any other equation. We have 1.5 times x, so we have to undo that by dividing by 1.5. And we get x is equal to 90. So that means that it's 90 miles between. And I'm not going to write out the cities. We can see the cities here between Cleveland and Pittsburgh. Example number 2, on a road map with a scale of 1.5 inches equals 60 miles. Go back. The distance between Pittsburgh and Philadelphia measures 7.5 inches. What is the actual distance? Okay, so we have inches here, we have inches here. So we're dealing with 1.5. And this time I'm not going to put the labels there. 1.5 over 60 is the same as 7.5 over our mystery. Cross multiply. 60 times 7.5 equals 450. So we have 1.5 times x is equal to 450. And now I take that 450, again, an equation like any other, divide by 1.5, divide by 1.5, I get x is equal to 300. So it's 300 miles between Pittsburgh and Philadelphia. Okay. Okay, so next page. Some different types of problems here. The first one is a map, and that's exactly like what we see on the first page. So I'm going to do example number 4 with you. Example number 4, you got to be careful because there's an extra number. It looks like we've got 4 numbers already. Remember, in each one of these, we're trying to find the 4th out of the 4 numbers. We're trying to find the missing piece. So the first thing is the drawing of the building to the right has a scale of 1 inch to 30 feet. Okay, this is the scale drawing to the right. So in the same fashion as what we've been doing, we want to write inches over feet. So what do we know? We know that we have 1 inch to 30 feet. How much do we have on the building? So let's look at the question here. What is the actual height? Well, the height is this, how tall this object is. So what we know is on the scale drawing, it's 1.25 inches. What we don't know is the actual number of feet that that's equal to. Okay, so we set it up just like that. So every time, all we're doing is trying to find the inches over the feet in this particular type of problem. Sometimes it's miles, sometimes it's different units, but The idea is what you set up here is that cross product. Okay, so I have 1x. 1 times x is 1x. And then I have 1.25 times 30. And I'm going to actually calculate that. Get the calculator out. 1.25 times 30 equals 37.5. Okay, so now I have to divide. Well, it's just a 1 that we're dividing by. The number in front of the x, whatever that number happens to be, I divide by that number. So that means the actual height is 37.5 feet. That's how tall the building is. Okay? So that's how we take care of that one. We have the same type of problem in example number 5, so I want you to do that one. And the same type of problem in example number 6. The only difference here with number 6 is that we have mixed numbers. So on your Google Classroom, within your Google Classroom, you still have the calculator soup. You can also just do a search on the internet for calculator soup, find a fractions calculator. If you're using the calculators that I have in my classroom, so we have 1 centimeter rather to 2 3/4 feet. In order to put 2 3/4 in, the way you actually type that is I'm going to actually write it out here. You type in the 2, and then you find this button that looks like this on your calculator. Okay, and that represents our mixed number. So we type in the 2, hit that button. Then we type in the 3, and we hit that button again. And then we type in the 4. And if you hit equals, you'll see that that gives you 2 3/4. It'll look like this, 2, an underline, and 3/4. Okay, let me verify that I'm telling you the correct thing. Yeah, it'll look exactly like that. This just means and. Okay, so when you're setting this up, you still have the same concept. You're still dealing with 1 compared to 2 3/4. And if the length of the living room is 5 1/4 centimeter on the scale drawing, well, the centimeters was on the top. So the 5 3/4 has to go on the top. And then we're looking for this. Now, when you actually do the calculation, when you're multiplying this times this, you need to use the ABC button, okay? So we would type in 2 ABC 3 ABC 4 times 5 ABC 3 ABC 4. Okay, and then you hit equals, it's going to give you that answer. Okay, so I'm going to leave that one for you. I want to skip forward. To this one right here. The rectangular floor of a classroom is 35 feet in length and 28 feet in width. A scale drawing of the floor has a length of 7 inches. Okay, so when we're dealing with that, we want inches over feet. So the inches that compares to is the length. It says the length is 7 inches. Well, we know the actual length of the room is 35 feet. So what are we looking for now? We want to know the inches first, and then they actually want us to find out the square inches or the area. Well, we got to figure out what x is first. So this is 28 feet for the width. So we want the number of inches for the width. Okay, so we do the same thing. We cross multiply 28 times 7, and we get 196. And 35 times x is 35x. Okay, so then we have to divide. So we take 196 and divide it by 35, and we get 5.6. So on the drawing, the shape is 7 inches by 5.6 inches. So I can actually draw that out. 7 inches by 5.6 inches. And area is equal to the length times the width. So in order to figure this answer out, you need to multiply those two dimensions. So I'm going to leave that for you to do as well. Okay. And let me take a look at the last page. On the last page, this last problem, what is the scale factor of the scale 2 centimeters equals 5 meters? Really, this is kind of an odd problem, but what they're doing here is they're saying that one of those meters, 1 out of the 5, is 100 centimeters. Well, if I have 5 of them, then that means 500 centimeters for every meter. Okay, so this is a 2 to 5, all right? And we know that we have 5 meters, and that's 500 centimeters. Okay, and we're looking for this. So again, cross multiply, and then divide. All right. Anything that I did not finish in this video is your work to finish. Okay. So make sure you have that done by, if you're a Monday, Wednesday student, you should have it done by Friday. If you're a Tuesday, Thursday, you should have it done by next Tuesday.